Hi, I'm Cheun. Today I will talk about silicon solar cell second time, and I will proceed in this order: series resistance and shunt resistance, and solar cell conversion efficiency. And let's talk about the series resistance and shunt resistance. There is two figures about that resistance factor, and we can see the first figure that means when the resistance surface is increased, the IV curve is changed like this, and that means the ideality factor, if the efficiency of ideality factor is decreased. And there is three factors of the series resistance. The first is uh, vertical resistance of whole devices, and second is the front the whole contact of the front and back metal line contact, and the last is self resistance of front and back metal contact. So that three factors are decrease the solar cell efficiency like this. We can see that the graph. And let's see the next figure. This figure means about the shunt resistance, and we can see the surface resistance is decreased. Also the IV curve is changed like this, and that means also the ideality factor efficiency is decreased. And this is about the shunt resistance, and the shunt resistance is increased. The whole resistance components are decreased, and this resistance is when we product the solar cell, there is make the defect, and that defect makes the shunt resistance. And another factor is when the electron hole pairs are produced at the inner solar cell devices. Originally that electron hole pairs are go to emitter or base, but the shunt resistance make the electron hole pair at the resistance component, and that makes the electron hole pair are recombination, so the efficiency of solar cell is decreased. So we can see that the resistance makes the solar cell efficiency is decreased, like first figure and second figure. And let's talk about the conversion efficiency. Originally there is 4 efficiency about the solar cell, but today I will talk about the first efficiency about this conversion efficiency. There is 2 efficiency. We can calculate the solar cell efficiency like this graph or this figure, and we can separate like ground solar cell or space solar cell. When we calculate the conversion efficiency at the ground, we can fix like 25 degrees and 1.5 AM and 100 millivolt per centimeter square incident light at the solar cell devices. But let's see the space solar cell. The space solar cell condition is the 1.0 AM, 100 millivolt per centimeter square incident light. Because the space solar cell, we do not care about the degrees, so there's no degree condition. And there is AM. AM means air mass. And air mass means when the sunlight at the incident at the solar cell there is scattering and many factors of the decrease of solar cell efficiency, and the error mass is the calculate when the sunlight is incident at the solar cell, like many factors scattering or many factors like decrease about the solar sunlight. So when we consider these many factors, so that we can define the error mass, and the error mass can calculate the conversion efficiency. And this graph is the temperatures. When we change the temperature, the IV curve is changed like this. We can see that the graph, the changing about the temperature. And this machine is solar simulator, and this simulator can make the environment about this condition or this condition. When we calculate the conversion efficiency, we make the condition very hard about the ground solar cell or space solar cell. So this simulator can help that this many condition get the environment at this many like conditions. So we can calculate the conversion efficiency more more yeah, more good, better when we use this solar simulator. So thank you for listening my presentation, and I will let's meet maybe 2 weeks, next 2 weeks. Thank you.